Today, we're going to talk about combining like terms and distributive property. We'll start by looking at a polynomial to discuss some terminology that you should be familiar with. A polynomial is simply a string of terms that are either added or subtracted. The polynomial we have is 3x cubed minus 2x squared plus x plus 5. Our first term is 3x cubed. Notice when there's an exponent of 3, we say cubed. Our second term is negative 2x squared. You might be a little confused here and think, wait, she just said minus 2x squared. You need to know that minus and negative are the same thing. This indicates that the 2 is being subtracted, therefore it is the same thing as a negative 2. You might recall that subtraction is the same thing as adding the opposite, and the opposite of a positive is a negative. So this could be written as plus negative 2x squared. Our third term is positive x. There's no number there, but you must understand that if there is no number to the left of a variable, it's an understood 1. So that is the same as plus 1x. Finally, we have our last term, our fourth term, of positive 5. Notice the 5 has no variable, therefore it is called a constant. Let's go over these definitions quickly. A coefficient is a number being multiplied by a variable. So in our first term, the coefficient is 3. In the second term, the coefficient is negative 2. Coefficient of the third term is 1. And there is no coefficient in the last term because there is no variable. The last term, the 5, is a constant, which is a number by itself. A variable is simply a letter representing an unknown numerical value. So in this case, we have a variable of x in 3 different places. The value of each of these individual terms will vary depending on what we plug in for x. If x is a 2, then our second term would be negative 2 times 2 squared. 2 squared is 4. 4 times negative 2 is negative 8. If we plugged in a 5, then we would have 5 squared is 25 times negative 2 is negative 50. So that value is changing or varying depending on what we plug in for x, our variable. And lastly, we have power. A power is simply an exponent. So here we have in our first term a power of 3, our second one a power of 2, and our third one, we don't see an exponent or a power, but we know that that's an understood 1. So in our third term, we actually have an understood 1 coefficient and an understood 1 power. Now we're going to move on to talking about like terms. Like terms are simply terms that have the same variable and power. Same variable and power, or no variable at all, such as constants. So any constants are considered like terms with each other. When you're asked to combine like terms, or the directions may say simplify, you are just performing the indicated operations to write your polynomial in simplest terms. Let's take a look at these two right here. Our first one, we have negative 5x minus x. So our first term is negative 5x. Our second term is negative x. We have no coefficient on the second term, so therefore we know that we can slide in a 1. So we have negative 5x minus 1x. Now, if we think of these in terms of being a negative instead of subtraction, I'm actually going to rewrite this as negative 5x plus negative 1x. Now it's very easy to see that we have the same signs. These are like terms because they are both x to the first power. Therefore, we can combine them. So this is the same thing as saying I have negative $5 in my account, and I am subtracting another dollar, which means that I will now have negative $6. So remember, if the signs are the same, you add and keep the sign. You do not change the exponents of a variable when you are adding or subtracting. Let's look at our second expression, 2n minus 6n. Again, we have like terms because we have an n to the first and another n to the first. We have a positive 2 and a negative 6. Those are opposite signs. Therefore, we will subtract. 6 minus 2 is 4n, but you keep the sign of the larger number. So negative 4n. Oops. Let's try a couple more here. Okay, now we're getting a little more complicated, more terms. Okay, so here we're going to look for like terms. Let's start with the terms that have x to the first power. Here we have 1x. Here we have minus 6x. So I'm going to write these 1x minus 6x. Plus, now let's look at our other terms. We have two constants here. We have a plus 6 and a plus 10. So we will add those together. Positive 6, positive 10. So we'll start by combining these like terms. 1x minus 6x. Positive 1, negative 6. Those are opposite signs, so we will subtract. 6 minus 1 is 5. Take the sign of the larger. Next, we will combine our other like terms. 6 and 10 makes 16. So the simplified form of this expression is negative 5x plus 6. Our next expression to simplify, we see that we have two constants, 7 and positive 1, and we only have one term with a variable. If there is only one term with that variable and exponent, then there is nothing to simplify. You simply bring it down, negative 2n. Now we will combine our 7 and our positive 1, and that makes 8. So negative 2n plus 8 is the simplified form of that expression. Notice when I write my simplified answers, I always put my variable first. This is called standard form. When you are writing an expression in standard form, you always start with your variable terms, beginning with the highest exponent, and then you will write in descending order of exponents, ending with your constants. Okay, now we have 4 more problems to look at here, getting a little bit more difficult. We'll work these quickly. In number 1, I see that we have an x cubed term, an x squared, another x cubed, and then an x to the first power. Okay, so we have a 3, a 2, and a 1 for our powers. That means we have 3 different variable exponent combinations. Okay, we can only combine terms that have the same variable and exponent. Let's begin with our highest exponent. We have 8x cubed, negative 4x cubed. 8x cubed minus 4x cubed. Next we have negative 4x squared. That's the only x squared term. And then finally, plus 5x. All right, I see this is the only one that I can simplify. 8x minus 4x, 8x cubed minus 4x cubed means 8 minus 4 is 4x cubed. There's nothing to combine with negative 4x squared, so I bring it down, and nothing to combine with 5x, so I bring it down as well. So now here is my final answer. This is in simplest terms. In standard form, I know it's in standard form because I'm beginning with the highest exponent and going in descending order. Number 2, I see that I have x cubed and x cubed, and then x to the first and x to the first. So I will begin by combining 2x cubed and negative 1x cubed. So that is 2 plus a negative 1, or simply 2 minus 1, which is 1x cubed. Notice I did not put a 1 for my coefficient of x. When it's a 1, you don't have to put it. I won't count it wrong if you do. However, you should be aware that on multiple choice tests, you would rarely ever, if ever, see a 1 as the coefficient. It would simply be x cubed. Next, I will combine my 7x and minus 3x, or 7x plus negative 3x. 7 minus 3 is 4. So the answer to this problem is x cubed plus 4x. Number 3, I see I have an x squared, and x to the 4th. There's only one term with x to the 4th, so I simply bring it down, 8x to the 4th. Next highest term is x squared. I have negative 6x squared, negative 2x squared. Same sign, they're both negative, so I add. 6 and 2 makes 8. Keep the sign, negative 8x squared. And then finally, there's only one term with x to the first, and there is no sign to the left of that term. Therefore, it's understood that it is positive, which is a plus. So plus 6x. Final answer there. And our last problem, 6 minus x minus 4 minus 2x. Okay, we have constants, and we have x to the first power. Negative x minus 2x. Same sign, negative 1, negative 2. Same sign, so we add. Negative 1 plus negative 2 is 3. Keep the sign, negative 3x. And then finally, 6 minus 4, or 6 plus a negative 4. That is simply 6 minus 4 is 2. Final answer. So there is a brief lesson on combining like terms.